Tested them. Okay, this is the last part of lesson 18. I wanted to show you. I didn't want to miss this part. Here we have log x squared plus x plus 4 base 5 equals to 2. All right, and we want to solve for this. So basically, what do we have to do to solve for this? What would be the first step? Yeah, you want to put it in an exponential form. Very good. So the base, which is 5, right? Log base 5 will be the base for the exponent, which is what? 2. Good. So this would be 5 squared equals to x squared plus x plus 4. Now what do we? Now that 5 squared, that's going to become 25, right? All right, now what? Yeah, you got a quadratic, right? So you got to set it equal to 0. And we end up with x squared plus x minus 21. Well, can we factor that? Can't factor, right? So now what? Yeah, we got to use the quadratic formula. So our a is 1, our b is 1, and our c is negative 21. So we go ahead and plug that into our quadratic formula, and we end up with basically negative 1 plus or minus the square root of 85 over 2. And so we can get a decimal. Now at this point, you can, to check it, you can just store this into x and then plug it, use this equation, log and then x squared. Well, actually, you could just plug it into the quadratic part. And as long as it doesn't come out to be a negative, then you know that it's going to be okay. But what you can do at that point is, what you end up with is 25 in here. And then 25, that's 5 squared, and so 5 and 5 squared, that gives you 2, and it checks. So you can do it that way. Okay? Questions with that? So that was the tail end of lesson 18. Okay, let's take a look. We're going to spend some time with lesson 19. And this is not nearly as long as it looks, because a lot of lesson 19 is what we've already covered in lesson 18. So we're going to do some more properties of logarithms. And here's some more concepts that you're going to need to know. Now this is log a times b, base a. So what we're going to do is we want to expand that. And when we expand it, sometimes when we have the logarithm in this form, we can't do anything with it. But if we expand it, sometimes we can solve problems from that. So that would make it log a base a plus log b base b. So here, if you have multiplication between your two terms in here, then you're going to add. And you're going to have both of them, they're all going to have the same base. Here we have division, a over b. So this would be log a minus log b. So anything, think of it this way, anything that's in the denominator, no matter how many terms you've got, are going to get a minus in front of it. Okay, and that makes it real easy to work with it that way. So let's say if we had a over b times c in the denominator, b times c in the denominator like that, then it would be log a base a minus log b base b a minus log c base c. Okay, so that's how that works. Now here we have an exponent. Now remember I was telling you that when you have a unknown, an x, as an exponent, you got to get it out of there, out of that exponent. Well, with expanding logarithms, you move that exponent out front, and it becomes a factor. It multiplies times the log b base a, like this. And now, when your x is down here, now you can solve problems because you've brought that x out of the exponent. Okay. Another thing we're going to be working with, remember I told you that your calculators only see base what? 10, right. And also Natural log, right? Very good. Base E. Okay, so log A base C. Now you see the log A, that's going to be the same. So this is log A base 10. And then this base here, that becomes log C base 10. Now your calculator can work with that. Well, the problem with using the change of base formula is you don't get an exact answer. Okay, so sometimes the problem requires an exact answer. Well, you can't use the change of base formula. You have to use the properties of logarithms for that. Okay, and you could also use natural log A over natural log C. Now the calculations turn out different between log A and natural log A, but when you go to divide them, they come out to be the same answer. Okay, and so you can use either one. All right, any questions with the properties so far? Okay, so we want to use the property of logarithms to find the exact value without a calculator. And so here we have log 9 base 6 plus log 4 base 6. Well, you can't use like 6 to the 6th power. You can't cancel here, right? You can't use the properties of logarithms. But maybe if we condense it, maybe we can. So we want to condense it to a single logarithm. And that's that log A base C plus log B base C equals to log A times B. That's a multiplication. That's a times period in there because I wanted to emphasize multiplication here. And so we do that. And so that becomes log 9 times 4. And can we get an answer from that? Yeah, because we could change 36 to 6 to the 2nd power, right? And now our base for our exponent is the same as our base for our logarithm. They're inverses of each other, and our answer is our exponent. Okay? Questions with that? So we couldn't get an answer separately when we were adding, but when we combined it, when we condensed it, produced a single logarithm, we were. And so that's how logarithms work. Okay? Questions with that? All right, find the exact value without a calculator again. Here, and I made this 5 really big because I wanted to emphasize that all of this up here is an exponent. Okay? This is 5, and then log 6 base 5 plus log 7 base 5, that's all an exponent there. So we want to simplify that. Well, what do you think we're going to do with that? Yeah, you're going to condense it, right? And so as a single logarithm, what's this going to be? Log 6 times 7 base 5. That's right. Okay, and that's what we get here. Well, 6 times 7 is 42, right? Well, because the base of your exponent is the same as your base for your logarithm, just like here, right? But here it's the exponent is first and then the logarithm, but the property is the same. Well, what's your answer? 42, right. And so it follows this property here where you have a to the log m base a. Your base for your exponent is the same as your base for your logarithm. And so your answer is your log, in this case, m. Okay, so in this case it's 42. All right? Questions with that? All right. Write as the sum or difference of logarithms. In other words, we want to expand. If this here was condensing, okay, some textbooks call it condensing or expanding, which I like. This one tends to use just sum or difference, which is fine. But I think expanding kind of helps to see what's going on a little bit better. Okay, natural log x e to the x. Okay, so we want to expand that, right? Since these two are multiplying, what are we going to do to expand it? Yeah, you're going to add it, right? So this is natural log x plus natural log e to the x power. Well, can we simplify natural log e? Yeah, because natural log is log base e, and this is a base e. The natural log and the e cancels out, and you just get x. Okay? Questions with that? And so our answer is just natural log x plus x, and that's it. We're done with that. So some of these you're just going to expand. Some of them you're going to condense. Some of them, if you can get a number, then you want to go ahead and put that number down if you can simplify it. Okay, use the sum and difference of logarithms for this. Okay, now here, why does x have to be greater than 2? Yeah, because of the x minus 2, right? The domain requires that for logarithms, right, that it cannot be, what can we not have? A negative or 0, right? Cannot have, so anything less than 2 will produce a negative or a 0. We don't want that, especially in the denominator. So that's why x is greater than 2. All right, so use the addition for terms that are multiplied, subtract for terms that are divided. In other words, the terms in the denominator, they're going to get a minus out front. So first thing we do is we go ahead and we look at this as a times b over c. So this would be log, and what base is this down here? 10, right? When there's no base, it's automatically base 10. So this would be log x cubed base 10 plus, and then here we change the radical to 1/2 power. So this is x plus 1, close parentheses to the 1/2 power, base 10. Minus, because this is in the denominator, log x minus 2 squared. Okay? Now, once we expand it, now we can move each one of these exponents down. Can't do it until you expand these first. So the 3 moves down, the 1/2 moves down, and the 2 moves down. Okay, now you see this x plus 1 and x minus 2 in parentheses? You cannot do anything with that because it's only with multiplication for inside this logarithm here can you expand it. So this is all you can do with that. Okay? Questions with that? All right. So let's take a look at the other half. And here we have natural log this time. And then we got brackets x minus 4 parentheses squared over x squared minus 1. And this is to the 2/3 power. Now there's different ways that you can do this. One way, which I like, is to go ahead and distribute that exponent, this exponent here, inside. And so this makes this 2/3 times 2. And so that makes it 4/3. And then this is x squared minus 1 to the 2/3 power. So you get 2/3 here and 2/3 in the denominator. Okay? Questions with that so far? Now we can go ahead and expand, right? And so we're going to put natural log x minus 4 to the 4/3. Okay? And what are we going to do with this denominator here? Minus, right. Natural log x squared minus 1 to the 2/3 again. Okay, questions with that so far? Oops, I didn't want to do that just yet. Okay, now what? Are we done?
No.
We're not done, right? What do we got to do now? Yeah, we got to move the exponents in front. Okay, so we do that, and now we're done. Cannot do with anything inside parentheses, right, when we're adding or subtracting. So that's it. That's as far as we can go. Okay, questions with that? Yes?
In the beginning, we talked about
Yeah, that would be this. So if this is in the denominator, right, then we put the minus goes in front. So anything in the denominator would get a minus in front. Okay? All right. Any other questions? Yes?
What would the domain be for that?
For this, here, because there's an x squared, what you're going to end up with is, forward and backward. It's either going to be in between 1, or it's either going to be in between 1 and negative 1 or outside of 1 and negative 1. And then we would have to consider that too. But we didn't get into those. So what you would have to use is a test point like 0. If we put 0 here, we would get a negative log. And so you could not, the domain would have to be outside of negative 1 and positive 1. But the 4 is no good either, right? Cannot have anything less than 4. So you would have to go from basically 4, you'd have to go from basically 4 to infinity, because you can't have anything less than 4. You can have anything less than 4 here, right? But you can't have anything less than 4 here. So this is going to take control, all right? Because you can't, like if you had a negative, you can have 2 here, right? But you can't have 2 here. So that's going to take priority, all right? All right. Okay. Here we're going to write this as a single logarithm. Okay? Well, first thing, like over here, when we did exponents last to expand, when we're condensing, we do exponents first. So this 2 times logarithm, what do you think we're going to do with that? That moves up as an exponent. So that'll be x plus 1 squared, log base 3. And then there's no exponent in front of here, so we don't have to move anything. Okay, so we move that 2 up. There it is right there. And now what? Yeah, now we're going to divide the 2. And it becomes a single logarithm. And here we have x squared plus 3 plus 2 over x plus 1 squared. Now, the problem that students have here is you have to make it into a single logarithm. And what students want to do is they want to put an extra logarithm down here because they confuse it with the change of base formula. Okay? So you have to keep the change of base formula and this straight in your mind. Okay? And so anything with a plus in front is in the numerator. Anything with a minus in front moves to the denominator. Okay? So you're going to condense it to a single logarithm, no more. Its base stays the same. Okay, questions with that? Okay, we're going to condense this one. All right, what do we do first? Yeah, move the exponent, right? So this would be going to be 21 is going to move up as an exponent. So in this case, we can simplify this because this cube root can change to 1 over 3 as an exponent, right? And so this exponent becomes what? 21 times 1/3. What does that become? 7. Good. Okay. Now, what's going to go in the is a single logarithm. What's going to go in the numerator? What's going to go in the denominator? This will be x to the 7th power here, this first one. Okay, what happens to this one? Numerator, denominator? Numerator. How about the 9x squared? What happens to that? Numerator. How about the log 9? Goes down into the denominator. Right. Well, let's see. Can we simplify this some more? Are you sure? Yeah, because x to the 7th times x squared, right, becomes what? We multiply the bases. What can we do with the exponents? Add, right? So that becomes x to the 9th. And what happens to the 9s? They cancel. And since this is x here and a 4 here, we can't do anything else. So that's our answer. Okay? So sometimes simplifying is, being able to recognize simplifying. That can be an issue there. Okay? Questions with that? Okay, this is already on Moodle, so if you want to go back and kind of fill in your notes, you can do that. All right, lesson 18 is too. Okay, so that concludes this lesson, as long as there's no other questions.